Hello, assalamu alaikum everybody. Thank you for joining me. We are going to start doing the supplementary practice videos, and I'm going to start with Unit 1.2. Now, these videos are intended for examination practice. Okay, so let's go. Let's hopefully you've got a pen and paper ready to try and do these questions with me as I go along. So just before we start though, I just want to say I've got a quick word. So these videos are supplementary to your own study. So what does that mean? What does the word supplementary mean? It means they're not standalone. So you don't just rely on these videos and don't look through the book. No, what you need to do is you need to read through the book once, twice, three times if you can. So that's how I would study. Read through the units once, twice, three times, make your own summary, do the questions, and then watch those videos. Okay, so those videos are supplementary, means addition. Okay, extra revision. Your book and your notes are the main source of study, and anything else that the teacher might have given you. And if you need extra help understanding the chapters, please go back and watch the original videos, which I might have posted a while ago. So when we did Unit 1.2, that must have been back in March or February. If you need to understand the unit, if you need help understanding the unit, then you need to go back and watch those videos. Okay, this is not an extensive explanatory video. This is a video where we do some exam practice questions. Okay, let's go. With that out of the way, um, so here's a quick question. Right, so this is the sort of thing that you might be getting in the exam. What I would like you to do is I'd like you to pause the video, try and do it yourself, obviously, and then unpause the video and do it with me. The SI unit for measuring distance is what? What is the standard international unit for measuring distance? And that is obviously the meter. Okay, and the symbol for that is just simply M. There are 1000 watt in a meter. Okay, so the first thing you need to understand is that you need to read the question twice. Um, so here we go. Meter. 1 meter has 100 centimeters. Here's a meter. I've got a meter ruler right here. A meter ruler has 100 centimeters. So, and each centimeter has 10 millimeters. Okay, so a meter ruler has 100 centimeters and each centimeter has 10 millimeters. So if it's got 100 centimeters and 10 millimeters in a centimeter, that means it's got 1,000 millimeters. Okay, there are 1,000 meters in a kilometer. The word kilo simply means 1,000. So you can have kilogram, which means 1,000 grams, kilometer, which means 1,000 meters, kilobytes, which means 1,000 bytes. Kilo just means 1,000. An object is in what if its position changes relative to another object? Obviously, it's moving, so that means it's in motion. It's in motion. If the position changes, that means it's in motion. And that's all relative to whoever's watching. I might be standing still or might be sitting down right now, like I look like I'm not moving. But if an alien is watching me from outer space, the Earth is moving, and so am I. The same way, if I'm sitting in a car, I might not be moving relative to somebody sitting next to me. But if somebody's watching the car from the outside and watching the car move, then I look like I'm moving with the car. Okay, the next question says, what is a place or object used for comparison to determine if something is in motion? So we just talked about that, a reference point. Reference point. So that is the point of the observer. Once again, I just want to remind you that if you don't understand those concepts, or if you're not sure about them, go back and watch the original video, which you'll find on the YouTube channel page. What is the length of the path between 2 points? Okay, distance. Distance is the length of the path between 2 points. And shortest distance is a straight line, but it doesn't say it's a straight line, it just says is the length of the path between 2 points. Okay, moving on. Okay, so this is once again the kind of question that you might be getting. You've got a graph here and you're asked to analyze the graph. On Saturday, Ashley rode her bicycle to visit Eileen. Eileen's house is directly east of Ashley's. The graph shows how far Ashley was from her house after each minute of her trip. So what you need to do in these kinds of questions is differentiate between the information that you need and the information that you don't need, because there is some information here that you obviously that are not relevant. Is it relevant to know that her name is Ashley? Is it relevant to know that she was on a bicycle? Maybe. Um, is it relevant to know that she was going to visit her friend's house? So what you need to know is analyze the information and differentiate between what's important and what's not important. Okay, let's go. So the first question says, Ashley rode at a constant speed. What does the word constant speed mean? Constant speed, if you remember, means it's not changing. Okay, constant rate means it's a straight line. It is not changing. The acceleration is constant, i.e. zero. So that's, sorry, the acceleration is non-existent in this case. There is no acceleration because it's constant speed. Ashley rode at a constant speed for the first 4 minutes of her trip. What was her constant speed? Well, let's have a look. So there it is, the first 4 minutes of the trip. So that's the first thing we need to understand. Where's the 4 minutes of the trip? Here it is. This region here, from there all the way to here is 4 minutes. What was her speed? Well, the speed is equal to the rise over the run. The speed is equal to the distance covered over the time taken. That's what speed is. Speed equals distance over time. Or in this case, where's the distance? Here's the distance. Here's the time. What was her constant speed? Well, it's going to be how much? It's going to be 800 minutes, or meters, sorry, per minute. Why? Why is it per minute? Because it says it right here. Now, normally, speed would be meters per second, but over here they've got it in minutes. So we've got 200 meters per minute. Make sure you've got the units right. Now, what if I wanted the speed in seconds, meters per second? What do I have to do? If I wanted the speed in meters per second, all I have to do is change 4 minutes into seconds, which would be 240 seconds. And then I'd have to divide 800 by 240, which gives me something like 3.4 or something. 800 divided by 240, which gives me 3.3 meters per second. Okay, and that would be 3.3 recurring meters per second. Okay, but that's not what we asked for. We just asked for the constant speed. What is the speed? The speed is 800 meters in 4 minutes, which is 200 meters per minute. Or meters per second. Next one, what was her average speed for the entire trip? How do we work that out? For the entire trip. So for the entire trip, it's going to be total distance divided by total time. Okay, the total distance covered divided by the total time it took. What is the total distance? The total distance is up to here. You see it? That's the total distance. So it's 1,600 meters. And what is the total time? The total time is 10 minutes. So it's going to be 160 meters per minute. What was her average velocity for the entire trip? What was her average velocity for the entire trip? Well, remember, this is a bit of a trick question because speed and velocity are closely related, except the only difference is that velocity has a direction because it's a vector, while speed is a scalar. It doesn't have a direction. So let's say, for example, if I'm traveling at 20 meters per second, that is my speed. If I'm traveling at 20 meters per second north, then that is my velocity. Okay, so in this case, what was her average velocity for the entire trip? It's going to be exactly the same, 160 meters per minute, except she lives, Eileen's house is directly east. So it's going to be that 160 meters per minute east. Ashley stopped to talk with another friend during her trip. How far was she from her house when she stopped? Well, let's see. Where was the moment on the graph where Ashley stopped? You can see she's going at a constant speed here. Then she stops for a while. Then she continues moving. So this is the moment here where she stops between 4 minutes and 8 minutes. So she stops for 4 minutes, doesn't she? 4 minutes. And what was Ashley's instantaneous speed 5 minutes into her trip? What is instantaneous speed? Now remember, we've got average speed, which is the speed for the entire trip. Total time, total distance divided by total time. That's average speed. Then we've got something called instantaneous speed. The word instantaneous means at that instant. So at 5 minutes, exactly 5 minutes, what was her speed? Well, at exactly 5 minutes, her speed was 800 divided by 5. Is that correct? Do you think that was her speed? 800 divided by 5. No, it's not. Because even though it's distance over time, at this moment here, she's not moving. Speed is equal to the gradient. So at this moment here, she's actually not moving, she's stopping. So her speed at that moment is actually 0 meters per second. Okay, so just be careful with that. Because if the gradient is flat, that's a terrible way for drawing flat. If the gradient is flat, it means the person's not moving. On a distance time graph, if the gradient or the slope is flat, it means the person is not moving. So at that moment, her speed is 0 meters per second. Okay, let's go, let's do some definitions. What is the average speed? Hopefully by now you know that it's the total distance divided by the total time. That is the average speed. And it's always good practice in the exam to actually just sort of put a slash or a mark on the sentences that you've used up. Velocity. What is velocity? Velocity is speed in a given direction. Okay, speed in a given direction. Now I'm hoping you've already done these. You've paused the video, have already done these, and now you're checking your answers. Okay, if you haven't, please pause the video, do these, and then check your answers with me. What is instantaneous speed? That is speed at a certain point. What is the slope? The slope is the steepness of the line or the gradient. And what is speed? Speed is distance per unit time. Okay. Oops. All right. Next. If the statement is true, write true. If the statement is false, change the underlined words or words to make the statement true. Now, this is a very, very common question in the exam. Okay, the kind of question you might get. On a distance time graph, a speed of 0 would appear as a horizontal line. We've just done that. So it would appear as a horizontal line like that. Let's have a look. Yes, in fact, that's what we got over here. That is a speed of 0. That means they're not moving. And so does it appear as a horizontal line? Yes. So we're going to write true for that one. The SI unit for speed is meters per minute. Not true. The SI unit for speed is actually meters per second. So this one is false. And in fact, it's meters per second. However, meters per minute is a unit of speed. Kilometers per hour is a unit of speed. Miles per day is a unit of speed. Any of those are units of speed. Why? Because simply amount of distance over amount of a certain time. So as long as you say, I've covered 100 kilometers in one day, that is technically a unit of speed. But the standard international one is meters per second. Okay, number 3 says a distance versus time graph will never show a horizontal line. False. We just saw one before. Will never show a horizontal line. That's a bit strange, that one. I don't know how to quite what they actually want. They mean vertical line. Right, yeah, a distance versus time graph will never show a vertical line because a vertical line just means in an instant the speed has or distance has increased. So that's what they mean here. A vertical will never show a vertical line. It can show a horizontal line because that means the person has stopped. Number 4 says the slope of a line is found by multiplying the rise by the run. No, it's dividing the rise by the run. Okay, dividing. That's from maths as well. So if you want to find the slope, if you found the gradient in a distance time graph, that shows you the speed, then it's going to be the rise over the run. Multiplying, and that's dividing. Oops, dividing the rise by the run. That is terrible. Let me write that again. That's better. On a distance versus time graph, a straight line indicates that the object speed is 0, not necessarily. So it just means that it's constant. So that is once again just means that it's constant, not necessarily 0. So this is constant speed, this is constant speed, that is even constant speed, and this is a constant speed of 0. But it doesn't mean that it's necessarily 0. Only in one of those cases, if it's flat, then it means it's 0. Number 6, speed is in a given direction is called velocity. True. Oops. Ah, that's too far low. I should be careful with that because it makes it harder. Right, next. A speedometer shows the what speed of a vehicle. It shows the instantaneous speed. Instantaneous, which means the speed at a certain time. Instantaneous. Sorry. Instantaneous speed. And I think actually that is an A. So it shows the instantaneous speed of the car, which means the speed at that certain point. I don't want the average speed when I'm driving the car. I want to know my speed at that point. Number 8 says to describe an object's motion, you need to know both its speed and what direction. Where is it going as well? Okay, number 9 says the what speed of an object is found by dividing the total distance by the total time. Total distance by total time immediately should always give you the idea that it's average speed. And finally, you've got a question here. Alfonso ran the 1,000-meter race in 2.5 minutes. Alfonso's average speed was what? Meters per minute. Now remember, it's the speed is going to be equal to distance over time. It's 1,000 divided by 2.5 minutes, which means 400 meters per minute. Okay. We'll see you in the next one. Best of luck.